Okay, yesterday we completed mathematical equation of first law of thermodynamics. As you know that, what is the mathematical equation of first law of thermodynamics? Delta U is equal to Q plus W. Now, when this mathematical equation is applied for various processes, we want to apply this mathematical equation of first law of thermodynamics for various processes. First process, that is isothermal process. Isothermal process. You know that what is called isothermal process? The process in which temperature of the system remains constant. That process is called as isothermal process. In isothermal process, delta U means change in internal energy is equal to 0. Then this equation becomes 0 is equal to Q plus W. Q plus W. Or we can write W is equal to minus Q. W is equal to minus Q. Or Q is equal to minus W. What this equation indicates? This equation indicates that heat absorbed is entirely used for doing the work. Heat absorbed is entirely used for doing the work. Now, second process, that is adiabatic process. Adiabatic process. Second process, adiabatic process. Adiabatic process. You know that in adiabatic process, Q is equal to 0. In adiabatic process, Q is equal to 0. Means there is no exchange of heat. You know that Q is the symbol used in thermodynamics for heat. So, in adiabatic process, Q is equal to 0. That's why delta U is equal to 0 plus W. That is equal to delta U is equal to W. Or minus delta U is equal to minus W. So, when we apply the first law of thermodynamics to adiabatic process, we get this equation. Now, third process, that is isochoric process. Isochoric process. Third process, isochoric process. What is called isochoric process? The process in which volume of the system remains constant. That process is called as isochoric process. So, in isochoric process, delta V is equal to 0. Change in volume, delta V is equal to 0. You know that the equation delta U is equal to Q. Delta U is equal to Q minus P external into delta V. External pressure into delta V. You know that delta V is 0, then this equation becomes delta U is equal to Q. Delta U is equal to Q. So, this equation indicates that change in internal energy is equal to amount of heat exchanged either between system or surrounding. Now, fourth process, that is isobaric process. Isobaric process. So, fourth process, that is isobaric process. Isobaric process. What is called isobaric process? The process in which pressure of the system remains constant. But in isobaric process, delta V is not equal to 0. Then we can write this equation as like this. Replacing here Q by QP, then we get the equation QP is equal to delta U. QP is equal to delta U minus plus P external into delta V. P external into delta V. So this equation is obtained when we apply first law of thermodynamics to isobaric process. Now, after completing this, we want to solve few problems on first law of thermodynamics. So, first problems on first law of thermodynamics. Problems on first law of thermodynamics. First law of thermodynamics. Problems on first law of thermodynamics. So first problem, calculate the change in internal energy. Calculate the change in internal energy. When a gas expands from 0.3 dm cube to 1.5 dm cube against a constant pressure of 20 kilopascals after gaining 2.67 kilojoule of heat energy. 2.67 kilojoule of heat energy. You know that when we read this problem carefully, calculate the change in internal energy means we want to calculate delta U, change in internal energy. When a gas expands from 0.3 dm cube to 1.5 dm cube against a constant pressure of 20 kilopascals after gaining 2.67 kilojoule of heat energy. So, according to first law of thermodynamics, delta U is equal to Q plus W. You know that we want to calculate here delta U, change in internal energy. The value of Q is given, that is 2.67. Q is equal to 2.67 kilojoule. Then we want to know what is the value of W. Value of W is not given. We want to calculate by using the equation for pressure volume type of work, because it is against a constant pressure. So first of all, we want to use the formula W is equal to minus P external into delta V, means V2 minus V1. Here V1 is 0.3 dm cube, V2 is 1.5 dm cube, 1.5 dm cube, and external pressure is given 20 kilopascals. P is given, that is 20 kilopascals. P is equal to 20 kilopascal. So first of all we want to find out W, then we can find out delta U. So here W is equal to, pressure is given, that is minus 20 kilopascal. Final volume is 1.5 minus 0.3. 1.5 minus 0.3, that is equal to minus 20 into 1.2, that is equal to, when we calculate this, we get, that is 24 kilojoule, minus 24 joule, that is equal to minus 24 joule. Now here Q is given in kilojoule, then we can convert it into kilojoule. That is, when we divide this quantity by 1000, it is converted into kilojoule. It will becomes, that is 0.024 minus 0.024 kilojoule. So here now delta U is equal to Q. The value of Q is 2.67 plus W minus 0.024, that is equal to 2.67 plus minus 0.024, that is equal to, the answer is 2.646 kilojoule. 2.646 kilojoule. So that is the problem on first law of thermodynamics. So in problem what we have to find? We want to find change in internal energy. Value of Q is given in kilojoule. Then W, we find the value of W by using the equation of pressure volume type of work, because it is against constant external pressure. So when we calculate this, we get the value of W in joule, and we convert this joule into kilojoule, and then we put this value of W in this equation. Then finally we get the value of Q, that is equal to 2.646 kilojoule. Now we want to solve next problem on this first law of thermodynamics. So first of all I want to write the next problem. A gas is expanded by supplying 500 calories, of heat, if the work done in the expansion is found to be, if the work done in the expansion is found to be 1.2005 kilojoule. Calculate the internal energy change in the expansion. Calculate the internal energy change in the expansion. the expansion. So once again, what is the problem? A gas is expanded by supplying 500 calories of heat, means the value of Q is given, capital Q, that is 500 calories. If the work done in the expansion is found to be 1.2005 kilojoule, calculate the internal energy change in the expansion. Means again we want to calculate delta U, and you know that according to first law of thermodynamics, delta U is equal to Q plus W. Delta U is equal to Q plus W. Now here you know that we want to find out delta U. The value of Q is given. It is in calories. It is in calories. That is 500 calories. And W is given in kilojoule. So we want to convert this Q into value of Q, which is given in calories. We want to convert it into kilojoule. So as you know, that is by multiplying, you know that 1 calorie is equal to 4.184 joule. That's why 500 into 4.184. So we get this value in joule, and when we convert it into kilojoule, we get the value of Q. You have to put this value of Q and W in this equation. So I will tell you final answer. Changing internally, you have to check it whether it is 0.8915 kilojoule. So once again, in this problem we have to calculate the internal energy. Calculate the internal energy change by using the formula delta U is equal to Q plus W. The value of Q is given in calories. We converted it into kilojoule. Then when we put this value of Q and this value of W in this equation, we get the change in internal energy delta U is equal to 0.8915 kilojoule. So when we multiplied 500 calories by 4.184, because 1 calorie is equal to 4.184 joule, that's why 500 into 4.184, first of all we get this value in joule, later on it is converted into kilojoule, and this value is kept in this equation for Q. W is given in kilojoule, so we get the final change in internal energy delta U is equal to 0.8915 kilojoule. Okay, now the next problem for homework, you have tried that problem. For homework, next problem, a gas expands from a volume. A gas expands from a volume of 5 liters to 30 liters, 5 liters to 30 liters, 30 liters under a pressure of 1.5 atmosphere, under a pressure of 1.5 atmosphere. Find W and delta U. Find W and delta U. Delta U supplied to the system if 2000 calories of heat is supplied to the system. So again in this problem we want to calculate delta U, that is change in internal energy, and also we want to calculate W. Here P is given in atmosphere. It is first of all, in last time you know that how to convert atmospheric pressure into that is Pascal or kilopascal we completed. So this convert this 1.5 atmosphere into Pascal. Then according to the formula delta U is equal to Q plus W. Here we can find out the value of W by using the equation W is equal to minus P delta V, and here then we convert these values of calories into joule, then we can find the value of delta U, similarly value of W. So this problem is for homework. The value of delta U is here and W is as like this, that is W is equal to minus 3797 joule, and the value of delta U is 4571 joule. So this is the problem for homework. Read the problem carefully. First of all, find the value of W, then put this value of W in this equation, convert these calories into joule, then we get the value of delta U, and then we get the value of W also. So that are the few problems on first law of thermodynamics. In next lecture we will start the next point of this chapter, enthalpy.